Now, this is one of my favorite topics in science to teach. This topic, I absolutely love it because everything around us, everything um, that we use, that we breathe in, whatever, we all deal with matter. Okay. Now, all of you may have done the topic before. That's fine. That's awesome. So that means that you could help me out a little bit. Or if you haven't done it, then awesome. Okay, you'll get to learn about it today. All right, but before we go into what is matter, we have to learn about some vocabulary terminologies dealing with matter. Okay, all right. So, first thing every science teacher is going to teach you is what is matter, a proper definition. Now, all of you are correct with your definition, but remember now, you're all even to take the BJC, and so you have to know proper definitions. So, what is matter? It is matter makes up everything. Your uniform that you're not wearing today, the air you breathe, and water are some examples of matter. Matter is anything that has mass, weight, and takes up space. And as you guys said already, which is an awesome job, there are three states of matter. All right. So as we were talking about what is matter, remember I said that you need a proper definition. Okay. Um, and when you write for a BJC examiner or a marker, you have to write properly. You cannot assume that they will know what it is you're talking about. For example, you can't just put matter is anything that has weight. Now, even though that is correct, it is only half correct. Okay. So you must write matter is anything that has mass, okay, weight, and takes up space. Now, before we get into the pictures and everything, we're gonna look at some definitions of what exactly or terms that matter deals with. Okay. All right. So some important terms to know is what is mass, what is weight, what is volume, and that last beautiful C word at the bottom is compressibility. Now, have any of you heard these words before or have not heard these words before? Okay, awesome. One person says she has. Good, good. So if you haven't, these are some new words to add to your vocabulary. Okay, and as I said again, if you want the notes, then definitely I can email you the notes. Okay, so I think everybody has a good definition of mass, which is the amount of matter in an object. Weight is the measure of gravity or the measure of force between two objects due to gravity. Okay. And if you did not know, on different parts of the earth, we weigh differently. Okay. And that's because the force of gravity changes. So if we were to go to outer space, we actually would have absolutely no weight. Anybody could tell me why? What about gravity, Ms. Roca? There is no gravity. Thank you, Mr. Ferguson, Miss Smith, Mr. Cox, Ferguson again, Mark B. Newton, awesome job, very good. So because there is absolutely no gravity in space, we absolutely weigh nothing, and that would be awesome for some persons like me. All right, then we have the term volume. Volume is simply the amount of space an object or substance occupies. And the last one, compressible, means to press together or force into a less space. Thank you. All right. So now gonna go into the states of matter. Now everybody is familiar with states of matter. So if you look, if you're, I know most of you probably are inside today. So if you look around your house or wherever you are today, I want you, the first state of matter is what we call a solid. Can you tell me some examples or write some examples in the chat of some solids that are in your space. Ruler, cup, pen, ice, blanket, cookies, books. Oh wow, y'all on the roll. Wall, bicycle, remote. So I'm guessing y'all either in your bed or in the front room watching TV or eating on the computer. The front room, yeah, yeah. Y'all on the computer, y'all eating, y'all watching TV. Awesome, good. So see, we could use technology to learn. Okay. Now the second state of matter is a liquid. Can anybody give me an example of some liquids other than the ones I have on the screen? Good. Juice, water, soda, water, juice. Good, good. Milk, Tampico. Mr. McKenzie, you drinking Tampico? Someone said alcohol. Well, I know you're not drinking alcohol. Okay, water, punch, tea, lemonade, hot chocolate, my favorite as well. Oil, yes. Paint, hand sanitizer. Awesome. Coffee. Good. And the last state of matter is air or gas. Well, I shouldn't use air because that's an example. So the last state of matter is gases. And right now I'm in a beautiful place and I'm experiencing the best state of matter underneath a tree. Okay, anybody could tell me what state of matter? It is a gas that I'm experiencing outside. Oxygen, wind, a fart. Wow. Breeze, good. Oxygen, air. Very good. Very good. Y'all smart. I have the smart class today. Very good. Hydrogen, awesome. Some are toxic gases, yes. Very good. Okay. So on the screen, add into your list because all of you are very, very intelligent. You can also see some other examples of the three states of matter. And I'm just going to pull out one or two. So solid, I have, well, an apple. Anything that's hard normally is a solid that has a fixed shape. Liquids, water, juice, milk, as you said. Soup, some soups are liquids, rain, good. And definitely gases, wind, oxygen, steam, fog. Those are some examples. Okay. All right. Moving right along. Now we're going to look at why we consider some states of matter. I love you too, Mr. McKenzie. Thank you. So, why some states of matter are classified as solids, liquids, and gases. Okay. Now, as I said, definitely will email you your work. And the first state of matter is a solid. So, the characteristics, I'm going to give you 1 minute to read the characteristics. I will email it to you, Mackenzie. I will email it to you, or I will send it to your email. That's fine. Okay. All right. So, characteristics of a solid. Particles are closely packed together. It has a definite shape and volume. Particles may vibrate, but do not move. So I'm going to look for something around me that I think might be a solid. Would you consider this to be a solid? Yes, definitely. Why? Okay, I saw something about plasma. I'm going to get back to you in a minute. Okay, it has a fixed shape. Good. Particles are closely packed together. Good. They vibrate. Particles may vibrate, but they do not move around. Okay. My next example. And cannot be compressed. Awesome. All right. My second example. Would you consider the leaf to be a solid? Yes, Shema nodded. Yes, okay. Now you got to tell me why. Why would the leaf be considered good? Particles are packed, closely packed together. Good. Fixed shape. Good. All right. Awesome. Very good. And so we already know some examples of solids. Okay. And in my examples, I have ice, a mug, a pencil, and a book. Okay. And our diagram shows we use circles. Okay. We using circles in this PowerPoint to show you that the circles are tightly together. They are compressed together. So if you hit a solid, it doesn't move. Okay. The second type of matter is, well, these are some examples. Okay. We already know this. So I'm just going to let you see. Are we allowed to use a mic? No, because we might get a lot of feedback. So we only want the instructor to use a mic. Okay. But in the upcoming sessions, we will probably have a chance to use a mic. Okay, we just wanted to get a feel of how many persons would be on. Okay. And then I don't want some kids to be able to hear me and then they having feedback from somewhere else. Okay. All right. So the second type of, thank you. The second type of matter or state of matter is a liquid. Okay. I'm going to give you a minute to look at liquids. Characteristics. So the second column, 1 minute, you could look at liquids. Where is my YouTube model? All right, if anybody has any questions or if I'm going a little bit too fast for you, then just let me know. Thank you, Mr. Adley. I'm not sure the schedule. I think I'm not sure. I'll have to find out to see when you have me again. Okay, so I'll let you know. Just trying to pull up my YouTube video for you, so after we're done, you could have a little, you could watch something. All right, so everybody's good with characteristics. So the first characteristic, particles are loosely packed together. They take the shape of the container. It has a definite shape, definite volume. Particles may vibrate, but they do not move. Okay, and I saw someone earlier that said water, I think it was, okay, and water is of course our universal example when it comes to all states of matter. So as we can see in the diagram on the end, let me see if I could use this, y'all, because I just learning this too. Okay, so we all know if this your first time, this mine too. Well, third time. Okay, so okay, somebody said I'm going too fast. All right, so I'll slow down a bit. Okay, so far we have looked at what is matter. And don't worry about the writing portion. I said I will email you. Once you drop your email in the chat, I will email you the PowerPoint. So whenever you need to go back or if you need to read on your own, that's fine. I will email it to you. So we looked at, now I'm not sure. Once you drop it once, I'll be able to get it. Okay. All right. So far we've looked at matter. What is matter? 3 states of matter, which is the first one is, who could tell me what's the first one? What's the first state of matter? A solid. Good. Okay. A solid. And I'll go back for you on the PowerPoint to the person who said I'm going a little bit too fast for them. Okay. And as I said, I'm learning as well with the Zoom. So just bear with me. Okay. All right, so going back, the solid is packed close together, has a definite shape and volume. So you can't change a solid. Once it's made, or once you could find something that's already with a shape, it's very unlikely that you can change that shape. Okay, unless you do something to it. We're gonna talk about that almost to the end. Unless you do something with a solid, it very rarely changes its shape. Okay, and so in the last column, we could see that a solid, or we use circles. Okay, so a solid is tightly compressed together. And someone, Mr. Ferguson, said a sponge. Okay, even though it's very soft, it is still an example of a solid because it has a shape or fixed shape. All right, then we moved on to liquids. So we said that liquids are loosely packed together. They are packed together, but they're a bit more loose. So you could actually get in between a liquid. Okay, you could drop something in your liquid and it will go right through. And most of us are familiar with, I guess, stirring Kool-Aid, right? Once you take your spoon and you mix your Kool-Aid, it isn't hard to get your spoon in it. Okay, so they're loosely packed together. Liquids take the shape of the container. So whatever you put a liquid in, if you put it in a circle shape, a square shape, whatever shape, it's going to take the shape of that container. It does have a volume, and particles may vibrate, but they do not move around. And some examples are water, shampoo, and juice. Yes, Kool-Aid is a solid, yes. Until you mix it with the water, then it becomes a liquid. Okay. All right. Now tea is also a liquid. Yes. Very good. And then on the end portion, as I was saying before we went back, the diagram, we use circles again. And so the circles, are they tightly compact together? No, they are loosely compact together. Okay. So some examples of of liquids in nature is a river, the juice. Now, I'm not around any liquids today. I don't see any liquids in my background or where I'm at. Okay. So unfortunately, I can't show you any liquids from my part. Okay. Waterfalls, good. Oceans, rain. Okay. When Kool-Aid powder turns into liquid, good. The beach, well, have to be a little bit more specific when you say beach. You have to say the ocean, good. So Tampico, Vitamil, good. All those are examples of liquids. Okay. Now moving on to the last state of matter. Mr. Cox said rum is a liquid as well. Okay, we have a question from Ms. Rihanna Adams. She's asking, if sponges are solids, how come we can bend and press them together? Very good question. Now, even though a sponge is what we refer to as a soft, it's kind of a soft solid, but it has all the characteristics of a solid. It has a fixed shape, it has a volume, okay? And so some solids are more rigid or more harder or more compressed than others, like the leaf and the rock. They are both solids, but of course the leaf is a little bit more flexible than the rock. Okay. All right. And then, as I said, we move to our last slide, which is gas. Okay. And gases or their particles are very, very far apart. They're very loose. Okay. They do not have a shape or volume. They take the space of whatever container you put them in. So if you're blowing up a balloon, of course, the gas is gonna take the shape of the balloon. Particles are very fast and they are compressible. Anybody could tell me what compressible means again? Yeah, can be squeezed. Good. All right, it can be forced down. Good. It can be pressed or squeezed. Okay, so when you think about compressible, think about a balloon. Like you could actually take a balloon and kind of squeeze it together, or you can even make it in any shape that you want to make it in. So that's kind of what compressible means. Okay, you can smash. Good. Mr. Macintosh, can you send your text again, please? I didn't see it because the chat is going very, very fast. Okay, so I'm trying to read and talk to you at once. Okay, and on the end, the diagram shows us that the particles are very loose. They're in no way connected or attached to each other. All right, so again, just showing you some examples of what is a solid, liquid, and what is a gas. So first picture, the one with the fire and the smoke, what state of matter will that be? Gas. Good. Now someone said earlier, do you think that's a toxic gas? Yes, definitely. Why would that be a toxic gas? It's a volcano? You sure look good. It's not a volcano. It can make you sick. It has high levels of toxic gas, such as carbon dioxide. Good. If you inhale it, you can get sick. Causes destroys your respiratory system. Good. Okay, it's okay, Miss Bean, your accent, if it's grass, well, it's actually old leaves and sticks, I guess, that they set on fire to burn it. But actually, from burning, they did create a gas, but it's actually a gas that could affect your lungs and your respiratory system. Okay? And someone said the branches and the sticks are solids. That is absolutely correct. All right? And then at the top, we have some balloons, and what state of matter is gonna be able to take the shape of the balloon? What state of matter? Good. It's gonna be a gas, air. Very good. Okay. Awesome job, guys. And then at the bottom, we have a nice cup of hot tea or coffee. Okay. Now, would you consider the coffee or tea to be a liquid? Yes, Mr. McKenzie, very good. But what is coming from the liquid? Yes, good. Steam, very good. Now, I want the smartest person in this group to tell me, you got to listen to the question good now. What causes, what type of energy, let me change the question. What type of energy is going to change a solid to a liquid or a liquid to a gas? Oh, very good, Shema. Very good. First answer. Awesome job. Good. Heat energy. Awesome. Oh, look at you all. You're so smart. Oh, man. They need to leave you all alone, mate. Very good. It is kinetic energy. Good. Good. Whoever says this is Miss Ritchie or Mr. Ritchie. Okay, it is a type of kinetic energy, which is heat energy. Awesome. It says write one state of matter in each box. Then draw circles to show that, of course, you have to answer this. Then draw circles to show particle arrangements for the state of matter in the triangle above. it. After, describe the particle arrangement in your own words on the lines provided. Color your particles when you're done. All right. So the first one, salt. Now, if we are arranging the particles in a solid, now of course I'm going to use circles, and bear with me. I said I'm learning, so don't laugh at my circles, please. Or the one thing that every solid has in common is that the particles are very closely packed together. Okay, I think I'm going to leave at that circle. So they're very, very tightly packed or compressed together. So nothing usually could penetrate a solid. Okay, so that's our first box in our state of matter. Oh, why does some drawing, eh? In any form. So how are the particles arranged in a liquid? And I want to thank you guys for joining me today. We have about 10 minutes remaining, but you guys have taught me so much in this session today. In our example, we said that it's going to be juice. All right. And then gas. All right. And so the particles are very, very loosely packed together. Okay. They only take the shape of their container. They're highly compressible. Okay. Meaning if you push gases together, it will push together. Okay. Very easily. Okay. I have a lot of gas behind me. I don't know if you could see the trees, the leaves moving in the background, but I have a lots of gases around me today. Okay. One of the main examples of gases is air. Now, I saw a lot of you talk about oxygen, and we also have carbon dioxide, which is the gas. We also have nitrogen, which is the gas, and water vapor, if you didn't know. Okay, those are all examples of some other gases. Every time we start the car, what comes out of the car is exhaust. That is also a type of gas. Okay. Before we leave the chat, does anyone have any questions?
Boys and girls, how are you feeling today? Are you sad? Or are you happy? Remember, these are called emotions or feelings. And our feelings or emotions, they change based on certain situations, right? Remember last week we learned that. We talk about changes. And today, boys and girls, we're going to continue learning about changes. Changes are all around us, everywhere, happening all the time. So that brings us to today's topic. The three states of matter, and then we're going to look at how they can change form from one to the other. Okay? Now let's talk about matter. What is matter? Well, let's look at the poster here. What is matter? I know you smart boys and girls, so you can read along with me. Matter is anything that takes up space and has weight. So you know what that means? That means that everything all around you is matter. The air that I breathe, the water that I drink, the food that I eat, and even the plate that is holding the sandwich. These are all matter. Now, these are different kinds of matter. The water is what we call a liquid. That's one state matter. The sandwich, the plate, is solid. The another matter, state of matter. And then remember I said the air that I breathe, that's matter. So clearly we can see that there are three main states of matter. And these are solid, right here. There are three states of matter. They are solid, liquid, and gas. Now, boys and girls, I'm going to teach you a song so you can remember the three states of matter. Now, I'm not the best one to sing, but I know you can sing better than me, so I want to hear you, okay? It's to the tune of The Farmer in the Dell, and it goes like this. Solid, liquid, gas. Solid, liquid, gas. Three states of matter are solid, liquid, gas. Now let me hear you sing it. I want you to bring down the house. Let your parents hear you sing it. Solid, liquid, gas. Solid, liquid, gas. Three states of matter are solid, liquid, gas. Good job. Excellent. Now, we're going to learn about each one individually, and so we can know exactly what they are. Now, remember we talk about solids. A solid is one state, and we want to look at these things that are on the table. There is a ball, a ruler, and a book. What do we notice about them? They all have their own shape, definite shape, and their shape will never change, no matter what you do with it. I can put the book in a box, it stays the same. This is a circle shape, and it stays the same. And this shape is it's a ruler, rectangular. So this is a solid. So one thing you need to remember about solid is that they have their own shape. Okay? Now, let's go on and look at liquids. These are liquids. You all know medicine, right? When you're not feeling so well, this is what we take. The doctor would give us. This is a liquid, and then there's orange juice, and the downy, which your mommy put in the wash when she's washing. These are all liquids. Now, let's talk about liquids. Liquids do not have their own shape. That's one thing you must remember. They're different from solid in that they do not have their own shape. Liquids take the shape of the container that you pour it in. So I want you to look over here. Okay? We know that water is a liquid. So, the water right now is in here. If I was to pour it out, let's see if I can come out a little faster. Okay? Pour it out. You can see that the liquid is taking the shape of the wine glass. It does not have its own shape. So if I was to pour this out, it would not have a shape of its own. Now I'm pouring the water into this little bowl. And what do you notice about it? Again, you see that the liquid is taking the shape of this container. And here again, there's a bigger bowl. And again, we can see that the liquid is taking the shape of this container. So, one thing, liquids do not have their own shape. Also, liquids, they can wet you out. They can pour out and it flows out smoothly. That's liquid. Now, not all liquids are good to drink. So some we can drink and some we can't. But I want you to remember that they do not have their own shape. They can wet you up. You can pour it out, they flow out. And actually you can see liquids. Just like solids, you can see solids. Okay, now let's look at gas. Remember, I said that the air that we breathe is a gas. And what do you know about gas or air? What do you know about the air? Is it something that we can see? No, we can't see air. So most gases we can't see. Most of them you won't see them, but you can feel them. So air is all around us. They do not have a shape of their own. They're somewhat like liquids, so they do not have shape. Now, if you notice here, I have a balloon. The state that this balloon is in, it says gases, but is a gas? No, it's not. Is it a liquid? Can't pour out, can't wet you up. No, it's not a liquid. But when I do like this, I'm putting something in the balloon and it's filling up that space. What is that something I'm putting in the balloon? It's air, right? Yes. Can you see air? No, but you know it can fill up the space. So air fills up a space, it spreads out. Most of it you cannot see. Now you can feel it. If I do like this, I can feel the air coming out, but I can't actually see the air. Now, so you know the name of one gas, air. How many more can you think of? Do you know names of any other gases? Yes, marvelous. What about the gas that when you go to parties or when you're having a fun day and you buy a balloon that is on the stick and it floats up in the air? Air is in that balloon. What do we call that air? Do you know? Oh, super! I think I heard the answer. It is helium. Helium is gas, form of gas. And helium is actually lighter than air. That is why the balloon floats up in the air. So, that's the name of a gas. Now, how many more do you know? The one that I breathe in when I do this. What is that gas called? Excellent. Oxygen. So we breathe in oxygen. Oxygen is gas. And what about the gas that we breathe out? We take it in, we let it out. That one is called carbon dioxide. So boys and girls, now you know the name of at least 4 gases, right? Air, helium, oxygen, carbon dioxide. And of course, there are many other gases. But when you get to upper primary, you will learn some more about these other gases. So you did an excellent job. Now guys, remember at the beginning of the lesson, I said we're going to be looking at the 3 states of matter, and we're going to see how they can change form from one to the other. Some of them can change form very easily. So water as we know it is a liquid. What happens when I freeze water? Well, this is what happens. It turns into ice. And ice is a solid. Freeze into ice. Ice is a solid. You can see that it has the shape of its own. So this is liquid turning into a solid. And then what happens when I boil water? Okay, the water is boiling now on the stove. And let's see, can you see what's happening? What's coming from it? This we call steam. You know, you hear when we say the steam is coming from a pot, but this is actually a gas. And it's called water vapor. So water, when the water is boiled, it changes to water vapor, which is a gas. Now, what do you think would happen if I was to leave this on for a while? Perhaps go to my bed, take a little nap. Okay? I think I heard the answer again. You guys are very smart. Yes, it will eventually boil out. There'll be no more water in the pot. And what is happening is the water is being evaporate. Evaporate it. Let's say the word evaporation. That's what is happening to it. It's actually turning into water vapor. And remember, water vapor is a gas. Now, how many of you ever walked home on a rainy day? Or walked to school on a rainy Monday morning, Tuesday morning, whichever day? You know, puddles are everywhere. And boy, we love puddles, right? Because we love walking through those puddles making splashes, right? But our parents ain't too happy with us doing that because, you know, we messing up the shoes and they have to buy us new shoes. But we do it anyway. But by the end of the school day, on the way home, puddles are all gone. Now, what do you think happened to the puddles? Did somebody come along and mop up the puddles? No, you're absolutely correct. Same thing is happening. Some of the water is being evaporated. Remember, evaporation means that it's turning into water vapor. And what causes it to turn into water vapor? The sun shining down, the heat from the sun actually changes the water vapor. Some of the water is turned into water vapor, but not all. Some of it is absorbed in the ground. That means it goes through the ground. So boys and girls, I am so happy and I'm so excited that now you know how matter is changed. Okay guys, now we're going to play a game. The game is called, is it a solid, a liquid, or gas? Now I have several things in the basket. And I'm going to show you one at a time and you shout out solid, liquid, or gas. Let's try my wallet. Solid, liquid, gas. You absolutely correct. This is a solid. What about the bleach? Absolutely correct. Again, this is a liquid. It can wet you up and we can pour it out and it is taking the shape of the container it's in. So excellent. Now this, you don't play around with this. This could be very dangerous and harmful to us. So we're not going to play with it, and it can mess up your clothes too. It can soak you, it can wet you, but it can mess you up. Good job. And what about this? What's inside? What is inside? Air is inside this. So is this a solid, a liquid, or gas? Excellent. It is gas. And then my shades. You know, we wear these on a sunny day. Is it a solid, liquid, or gas? It has the shape of its own. So it is a solid. Super job. And then we have the dish liquid. Again, we can see it pour. It's something that can pour out. It can wet me up, and it's taking the shape of its container. So this is a liquid. Excellent. And then we have tape. Solid, liquid, or gas. It's a solid. And a marker. Solid, liquid, or gas. It is a solid. Excellent job. Give yourself 3 taps. 1, 2, 3. Girls, I hope you enjoyed today's lesson learning about the 3 states of matter and how they can change form. Okay, you did an awesome job. You are indeed smart, boys and girls. Now, here's what I want you to do for me. Remember at the beginning of the lesson, we said that matter is everywhere all around you, right? I want you to make a list of as many solids, as many liquids, and the names of the gases that you remember. So awesome job today, and you do enjoy the rest of your day. Until next time.
A solid, a liquid, or a gas.